Moderator Shri Dinanath Akela Sir with bouquet. He is competent person for inspection and certification of boilers, certified lead auditor for ISO, system certified BOE trainer and BOE engineer, certified engineer. I request Mr. Chirag Panchal, please welcome Shri S. Shivkumar sir. He is a BE mechanical. He is a professional boiler operation engineer. He started his career as an engineer trainee and grown up to assistant general manager level, handled various responsibilities of commissioning, troubleshooting, performance testing over the 300 boilers of various types. Now, I request Mr. Anas Sheikh to welcome Shri Sachin Sangam Nerkar sir. Sorry. He's B Government College Engineering. I like to invite Mr. Anas Sheikh to welcome Shri Mukund Deshpande sir. He is head of corporate marketing, Forbes Marshall Private Limited, Pune. He has 32 years of experience in sales, marketing, and team leadership.
Yes.
Here's the little announcement. We have Yogesh Abhyankar on the place of Sri Sachin Sangam Nekar. Okay. Now it's time to hand over the mic to Sri Dinanath sir.
So thank you, and once again welcome back. This the third session of the day, right? So in these sessions we have also the very eminent speakers and great experience in this boiler field. So let's start with the first Sri Mukund sir.
Good evening all. Can we start? So this is in line with the theme of this conference, talking about the future. So I think what I will do is that in a quick 10-15 minutes I'll talk about the steam systems, what used to be the past and what's there in the present and what the future looks like for the steam system. Right, and then So in the past, if you see, the steam system was all about as an energy which is being used in the process, and then we used to see that there were different plants making the same product, but the energy which they were guzzling or energy which they were consuming were very different, which actually led us to a benchmarking exercise which we started in 2003, basically to look at why the different plants making the same products are consuming different kind of energy, which then we dwelled on what we called it as a benchmarking exercise. Then when we went deeper into that, we found out that in the simple steam system you have a boiler, and then you have the distribution system, then the steam gets used in the utilization which is in the process, and then of course there is a recovery system whereby which you recover the condensate and then flash steam and things like that. So we saw in that, and then we said when we looked at this steam system in much deeper for a different industries, then we looked at the boiler, especially the generation part, the steam, there are a lot of steam trapping and distribution losses which were happening, which were very different from plant to plant, and there were issues about the process trapping also. So basically what we were looking at that point of time, this is mind you somewhere around 20 years back when we were talking about the steam system. So we were basically looking at the way people were using the steam in the process. So we could find out that even if you bridge the gap between an average and the best plant in those days, then you had an opportunity to save about 20% or 24% of steam energy. Just to give you a simple perspective for this, even if you save about 100 kg of steam, or let's say 100 units of energy in the utilization, you actually tend to save 200 units of fuel which you will burn in the boiler. So that's the kind of the ratio between the generation and the utilization which has an impact. So when we looked at these industries, especially I have compiled about 4 industries which are relevant to this region. We looked at starch, we looked at soybean and the rice bran, and then also the oven plant, which is basically a textile plant. So in the 2003 to 2021, the span of about 18 years or 20 years, those differences which were there in the way the steam was being consumed in the processes, when we went deeper into that and then we started bridging the gaps by changing some things like, changing the steam trap, recovering the condensate, in some cases basically changing the efficiency of the boiler. So in each of these plants, actually we could make a difference in the specific energy consumption of these industries. For example, I'll just give you a soya. When we did this exercise in 2003, the best soya plant was actually consuming about 66 tons of coal, kg of coal per every metric ton of seed being crushed, whereas the average plant used to be at about 88. So over the next 18 years, when we did this exercise again in 2021 with those changes in the steam system and addressing the gap, the whole the ratio came down to 47 for the best and then the 51 for an average. So this is where this was purely, it took about 20 years to bridge this gap only by changing certain basic stuff in the steam, the way the steam is being utilized. This was again what I still call it as the past, because this is what people were more worried about. They were more worried about the steam consumption, and then they were making some corrections to bring the steam consumption to a desired level. But now, when you talk about the present steam system, which is here and now, I think we started realizing that it is not about only consuming or let's say reducing the steam consumption or optimizing the steam consumption. It's all about, the steam is nothing but a slave. The process is basically the master. So the process, the steam has to cater to the process need. So if you keep doing something around the steam consumption, doesn't mean that you have an impact on the process. That's what we started realizing over the last 5 or 6 years, when we looked at each of these industries as to why there is a gap between the best and the average industry for the consumption of fuel, then we said that it's simply not about steam, but I think we need to look at the steam consumption in conjunction with, let's say, the process parameters. So when we dwelt further into that, we said that the steam consumption in every plant varies because of different process parameters or dynamics. For example, there are lots of varying product mix within that industry. Changing product basket, lots of SKUs which people make. Even if you go to a simple personal care plant, they make about 50 different varieties of the personal care, or let's say a shampoo or in the skin cream and things like that. For each of these SKUs, the steam consumption actually varies because the process parameters which are needed are very different. So similarly, there are lots of different recipes which are involved in different products, which also made sure that the steam consumption was actually varying. And then there are lots of dynamic demand patterns itself. For example, in a brewery, you have a peak load, and also in the beverages, you have a peak loads when you have the bottle washer being heated from the beginning. Then in some cases you have a peak load in some industries which is much higher. In a brewery, for example, when the wort boiler comes into a play, and then you have a lows when only the bottling is running but nothing else is running in a brewery. Like that, there are examples in each of these process plants where the steam consumption varies because of the process demands. And then there are lots of seasonality issues also. There are lots of multi-utilities. Many of you who work from the chemical background know that in a reactor you use different kind of utilities to get that reaction. It's not only about steam, but you use the chilled water, you use the brine, and then you use many other utilities in order to get that reaction. So lots of multi-utilities or multiple utilities which are also impacting the steam consumption in the process. So one thing which we could understand when we did this exercise, which is in the present tense, is that every day, every hour, every minute, the steam consumption and the process parameters keep varying. So where is this is all going to lead us to? Then we said that we looked at simple process parameters. In a typical process parameters, these are the typical KPIs. For example, you have a productivity KPI, you have a rejections, you have uptime, you have energy intensity. Energy intensity, what I mean is amount of energy which is required to produce a certain amount of product, and then there are safety. So we understood that the expectation across all these parameters very clearly defined in every plant, but more often you get the reality which is very different from your expectation. For example, the productivity, what you expect as a plant owner, that you want to have 100% productivity, but in reality you end up being at 70 to 80%. Like that, each of these parameters in the processes had a different expectation, but the reality was very different. And the difference between the perception, or let's say expectation, and the reality was also to do with the way the steam was being used or a utility being used in the process. That's where we started drawing a correlation between the steam and the process, and then try to address some of these issues. I'm sorry, I think this is then we realized that there are three aspects which actually impact the whole performance from the utility side. For example, the design itself will be about 75% of these issues are only because of the design. We'll come to that as to how you address that. And there are some technological points which also impact the process parameters. And then the O&M practices, the way you are actually operating and maintaining your, let's say, a steam system in this particular case, right? So when we looked at this, this is an example of a design for for your consumption. This is a typical personal care plant, where you had the steam consumption, the peaks and the troughs. whereas the desired steam consumption on an average steam consumption is very different. So what people tend to do or still do is that they add up all the peaks and then arrive at the boiler capacity. If you do that way, for this particular plant, you would have wanted 4-ton boiler in order to cater to these peaks which come in the process, right? But when we got into the detail and further when we started mapping this consumption, we realized that these peaks don't come all the time, they come at different frequencies, and there is a pattern to these peaks. This is where you can actually introduce a concept of what we call as an accumulator, steam accumulator between the boiler and the steam system, and then by putting that accumulator you can absorb some of these shocks which come because of the higher or a peak consumption and try to optimize your boiler consumption, boiler capacity. When we did that, it came down to, I think, about half of that boiler capacity. You could do everything which is needed in that process, which resulted into 18% capex saving as well as the operations saving. This is about design, the earlier one. This is all about the equipment level. For example, this is a DT which is normally used in the solvent extraction plant. So there are again issues on the safety, operating parameters and qualitative, which is basically the productivity, specific steam consumption and hexane losses. These are the typical process parameters which are of importance in a desolventizer toaster which is being used in a solvent plant. So again, here the steam played an important role to ensure that you get these parameters. For that, what you have to do is to control the right pressure, right temperature, and then make sure that you have a control system which actually takes care of these different level, or let's say what we call it the compartment wise temperature control, which will lead to a proper hexane usage, or let's say minimize the hexane losses. So these were some of the things which, as a design and as a technology selection, as a combination of that, which led to a proper control of the process parameters by using the steam in a right way. And then when we look further into some of these processes, there are a lot of interplay of utilities in the process. For example, in a reactors, which I gave an example earlier, and then also in a dyeing machine in a textile, you have the streams of steam, let's say hot water, and the streams of steam, and then you also have a cooling cycle which actually precedes which basically follows the steam cycle in many of these applications. So this is where we actually looked at something, for example, this is the continuous, when we had the segregation of this steam from the cooling circuit, you can actually increase your condenser recovery factor and then make sure that the interplay of these utilities doesn't affect your process parameters. So again, if you do a right thing, when especially people think that because of the interplay of these utilities, people fear about contamination. That's the reason why they do not recover condensate, especially when it comes to a chemical reactor or maybe a dyeing machine, where they feel that because of these interplay of utilities, they feel the contamination occurs in the condensate, hence they don't return it back. But there is a way by which you can actually segregate it by using the right technology, right product, right product selection. By doing that, you can actually separate the condensate from the pure condensate from the contaminated one, and you can still use this particular condensate back in boiler. We did some examples like that or trials like this recently, let's say in Dr. Reddy's in Hyderabad, where we put this particular system and then we could realize that 80% of the time the condensate coming out of your chemical reactor was always pure, but only for the 20% of the time it was contaminated when there was a changeover which was happening. This something which which has been a myth in everybody's mind in the chemical plants, that most of the time this condensate is contaminated, but which is not the case. So these are the certain learnings which are now present days. With these learnings, we're trying to improve the technology and the product selection and make sure that the steam is being utilized properly, and then you still without compromising on the process parameters. So with all this, what we could do, I'm just giving you an example of a very unlikely industry for this region, which is a brewery. For example, in a brewery, when we started the work in 2003 to now, this is a very striking example. If you take the 2003, at the production level, which was there at the 2003, they were using certain amount of energy, which is just don't go by numbers. When they came to 2021, even though the production, which was almost 4 times, or let's say 3.5 times higher than the earlier one, the energy consumption actually improved by only, or increased by only about, the ratio between the production to the energy dramatically came down because of lots of things which we put in place, or the industry itself put in place in order to optimize the steam consumption. So I think by looking at steam and in conjunction with the process, you can actually make a big impact in the specific energy consumption of that particular plant. This is an example of a brewery, but this example holds good for any industry. That's what the present thing is all about. Don't look steam in isolation, look at steam in conjunction with the process, and make sure that your process parameters are not compromised, yet you can actually, by controlling the steam consumption through a right selection of products, technology, you can actually improve the specific steam consumption in a much better way. That's what the future is all about, or the present is all about. In the future, I think I just want to talk about one slide and then leave thoughts open for you guys. Is that where is the future for the steam system? I think in the steam system, the future lies in these 2 or 3 slides. One, this is the traditional way of looking at the process and the utility. All along, we have been improving, or we are putting our thoughts to improve the productivity part, which is the process side. At the same time, we are trying to drive the cost down for the utility. That's been the traditional way of looking at things. But what's happening, I think we heard many speakers talking about it since morning. There is emission pressure on these processes every day on the utility side, where there are a lot of curbs which are coming on the emission, and there are lots of curbs which are also coming on the discharge part, which is going to increase both your the treatment cost for emission, treatment cost for your discharge, which will add to your cost. But the process people or the utility people are constantly under pressure to keep driving the cost down. But it can only happen if you look at the process and then the steam or the utility in conjunction together. So the future would look like where, again, there will be a lot of pressure on the fuel changes, there will be a lot of pressure on the asset uptime itself in the utility side, and then there are lots of pressure which will be there on the process side in terms of utilizing the cost, how do you utilize the capacity part, and then asset uptimes and things like that. So I think the steam and the process integration is not easy, and then it's not so simple where you just keep producing more but keep using less steam. It's not this game is not going to go forever, right? Because there are lots of external pressure which will keep coming on the processes. I think the operational people and the utility people have to keep absorbing this pressure, but yet they have to produce the best, which is to have the steam consumption lower. I think this is where the game has to change. This is where I think we need to look at holistically and then apply the right knowledge for both processes and for the utilities, such that the final aim of driving the cost down and then improving the productivity we can achieve. So I think I'll leave with that thought, and then maybe something which if anyone has a question in the end, we can answer that. Thank you.
Thank you, Mukund sir. Now I'm just going to welcome to Shiv Kumar sir. Wonderful, sir, wonderful.
Good evening. Okay. See, socket events. I am traveling for almost 2,000 kilometers yesterday to attend this function. So, please to try to give us earlier slots, because how many of you from the user side? Please raise your hand. Boiler user side. Sir, almost 90% are from user side. So we are going to discuss about the user side and with the case studies. And after my session, I am going to ask you. Till now, I only interact with the sockets and write the presentation and send to you. Now you are all going to decide what is the presentation I have to give next year. You can give 10 subjects. I will do some 10 case studies and present to all of you. So that will be, more of, your requirements. That will be more useful for the requirements. I hope you will all agree with me. Let me go to the presentation. See, we are going to discuss about the efficient boiler operation and maintenance practices. So, let me start with the basics. The importance of boiler operation, maintenance, industrial process and power generation. It depends on the process, steam requirement, power generation and cogeneration. What is based on that only boiler is decided. What capacity, what is the fuel, what is the fuel source availability, steam quality requirements, steam demand, flexibility, load pattern and achievable efficiency. All these things are based on this only the boiler requirement is decided. Now, efficient boiler operating practices, what are the we need to monitor, or what are the things we need to take care? Commissioning trials, which is very, very important. All the commissioning trials of the equipment, as well as the pre-commissioning trials, and slow firing, chemical cleaning, steam blowing, all the DP study, fluidization study, all for AFBC boiler. For a waste heat recovery boiler, again, refractory curing, refractory curing, steam blowing, then safety. All these pre-commissioning trials are to be carried out perfectly, and then it is to be recorded, because later on any deviation you need to refer the documents for corrections. Then protection checks. This is very, very critical. See, how many of us doing the protection tests, how frequently? Any please. Yearly once you are doing? Yes. Very good. After major overhaul. No, see, IBR, that is IBR maintenance overhauling we are doing. After that, again restarting, what are all the checks we are doing? All protections. Say one or two. Very good. Then it should start with the drive sequence. So for AFBC boiler, ID fan, then start permissive, PA fan, then short permissive, FD fan, then fuel feeder. This is the drive sequence trial. Then for boiler feed pump, DP switch, DP switch high, pump trip, then drum water level in the deaerator, pump trip. These protections are very critical, and then boiler drum level low, fuel firing cut off. So this checks every annual, at least after major overhaul. Everyone should record and keep the record and present to the boiler inspector. And also after overhauling, do the safety all checks and record the data and present, because these are all the safety. It is not only for the equipment, because equipment don't speak, it is speaking through us. Equipments, we are the ambassador of the equipments. So and boiler directors or whatever the inspection authority, they completely believe on us, because they conduct exam, they certify us, then when we go to the field, they think that we will do a good job. But we should try to do the best, whatever out of our knowledge, we should try to do the best and maintain the boiler. So all the protection checks are very, very important, and I have seen many accidents in not only small plants. Few years back, there was a very big accident in UP. It was a major accident because the protections were bypassed, nothing else. So whatever the OEM suggested protections, we need to maintain. Then regular walk down checks. So honestly speaking, today, see, when we all started the carrier without a round in the field, we never come to the control room. Today, DCS operator never goes to out of the control room. They all just come and sit in the, I don't know how this practice is getting deviated. Unless we know the equipment, how we do the corrective actions. So if you go to the equipment, that will speak. Fan, that will give a sound. Equipment, any leakage, that will give a sound. Once you go walk through the plant, then you will understand the problems and make an action plan for corrections. Monitoring and targeting. Monitoring, what are the monitoring? So we need to monitor the boiler efficiency, specific fuel consumption, specific power consumption of a boiler, pressure drop across the system, water, steam, flue gas, everything. All the data we have to monitor every day and then record it. Then only you understand. If there is a aerator leakage, then automatically the ID fan speed is going to be more, or the damper opening is going to be, it will reflect in the power. So once we monitor all the data, then we can understand the equipment better and do the maintenance better. Standard operating practices. So we need to study. See, all the documents are prepared by the OEMs for us to upgrade ourselves. We need to regularly spend some time to study the SOPs. Maybe 10-15 minutes is okay. Some system you study and thorough with that. That will give you a better, you will get more confident. If you are confident, you do a good job. Then combustion optimization. Combustion optimization, you need to monitor the fuel size, air adjustment, O2 level, exit gas temperature, furnace temperature, everything you need to see, and LOI. All these things will give you data. If you monitor everything, then you will understand where you need to attack and address. Performance evaluation. Performance evaluation, daily basis, you can monitor the steam fuel ratio and then evaluate. Once in a year, at least do with some agency, audit the plant, audit the boiler, and understand what is the efficiency. Keep the record, just like what we are doing with the boiler overhauling inspection. Same way you do performance audit of the plant and take then that will be a benchmark for the rest of the year. You will understand where we are lagging, what is the correction need to be done. Then energy audit, same thing, water treatment, quality, water treatment. So boiler operator should also be thorough with the water treatment, because what is going inside, if any deviation in the water, that is going to affect the entire process. Then training. So overall I see the training is a major requirement in all the industry, because we don't give importance to the training. So please give more training classes, small subject. Even the people who are working in the field, they can conduct the training classes when they operate the plant. Fuel quality, see again, these are all the, when you select the boiler, you should understand what is the fouling character, slagging, water quality, scale formation, corrosion, steam quality, these are all going to be the impact. Insulation, if the insulation quality is bad, then also your radiation loss is going to increase and it is going to affect the boiler performance. And qualified operation, engineers and operators, that is more important. So qualified engineers and operators and discussion, group discussion, these things will improve the knowledge of the operating staffs. Why the boiler maintenance are critical? To achieve maximum availability of the boiler, maintain reliability and safe operation, operate the boiler with maximum load and efficiency to meet safety regulations. How do you access pressure parts? Already Mr. Aribakti, he discussed about the NDT methods. So just for you can just go through and you can have a discussion. Let me switch over to case studies. So this is very important. See, one is failures and maintenance, design and precision. This method of design and precision is taken care for reliability and purpose. Then the insulation and design, these two factors will be the correction at the initial stage itself, so that the correction cost and time is less. Then if you move to the predictive, again predictive and preventive, these are all corrections or periodic maintenance. The cost is going to increase, and also then further failure. Failure means again the breakdown and the loss of product, loss of cost implication in the correction as well as production loss. Both way it is going to affect. Failure identification, YY analysis, fishbone diagram, that is cost effective analysis, failure modes and effective analysis, root cause analysis, RCA. Energy management, auto controls, real-time monitoring, energy efficient equipment installation. These are all the energy management and automation. So there are a lot of upgraded equipments in fans, pumps. There you can save energy by implementing the new technology. Documentation. We are most of our plants, small size plants. I forget about the bigger size units, ONGC and all, they will be very good in documentation. Smaller plants, the documentation part is very, we need to improve a lot, because they have to keep performance indicator, they have to put where they are, they have to plot and monitor. Commissioning documents, they have to maintain daily generation report, parameter log sheets, monthly generation report, monthly performance report, failure analysis report, training schedule. Even training schedule you mark and put. Anybody comes for the audit, you can show this many trainings we have conducted. This is what our status. Standard SOPs, and SOPs also to be reviewed periodically. Emergency operating procedure, that is to be displayed in the control rooms. Operation routine checks, 5 years program, safety awareness program, safety department MIS report, commissioning document, maintenance schedule and procedure, welding procedures. Welding procedure, many people now see 84 kg T91 tubes are coming. The welding procedure and the pre-welding, post-welding treatments are very difficult. Have a knowledge and talk with the people, understand, even though you are an operation person, understand with the maintenance team and talk to the welding specialist people, understand what are the procedures involved, what are the importance in that welding, selection of welding rods, understand that. Then daily maintenance report, spare inventory control, need to have a spare inventory control, tools list, asset details, spares verification, lubrication schedule for all the equipments, rotating equipment, condition monitoring schedule, performance test reports, that all the time performance test report should be available with the in charge, boiler in charge. Whoever the manager should have that report, and then it is to be discussed with the operating staffs. Then roles and responsibility of the individuals, that also we can fix it and monitor. equipment history card, safety permit system, shutdown report. Shutdown report, so what is prior, what is after. That will give you a fairly idea about what sort of maintenance we carried out. That will help you even for the next time when somebody comes, you can show this is what after the maintenance. So few case studies I have put. This is an 54-ton boiler. We have experienced during commissioning that there was a very high air pressure drop across the APH, almost 250 millimeter of water column air pressure drop. Then we identified the pressure drop and we have informed the customer, because though it is not supplied by us, we are only a commissioning and then O&M operator. We inform them this is what the problem is. We will not in a position to achieve the full load. Then that time after commissioning there was no load requirement, only 30-35 tons they were comfortably operating. Then second year gone. Third year they increased the process plant requirement. Then as it has come. So 45 tons we are unable to reach. Then we opened the air preheater bypass and run. The exit temperature was high, so we are losing in the efficiency side. Then we changed the aerator with a new design that we did ourselves as a total EPC contract. Almost they spent 1 crore for the complete aerator replacement, and the payback period is 5 months, and the total saving is 2.65 crores in a year, almost 3 years over now. So these sort of things can be done only by doing a performance audit on regular basis. Otherwise, it will not be in a position to understand. Sorry?
Oh, please carry on, sir.
The other 45-ton AABC boiler, there is a problem of higher LOI and higher back-end temperature. Understand the fouling character of the fuel, that NA2 was very high and there was a 35 to 40% fines. Then we adjust the pressure gap and we reduce the LOI, and also there was a fouling. Because of fouling there was a back-end temperature increase that we address with cleaning, and we ask the customer to change the fuel. So, and after that they are doing every fuel analysis they are taking, they will do on ashing analysis. That ashing analysis will give what is the sodium, potassium in the fuel, the fouling character they understood, and then we are given a document for them to assess, then that problem is overcome. See, as a company, we are doing O&M services, pre-commissioning, commissioning services, boiler troubleshooting, performance tests, energy audit, and open bottom design for high ash content fuel, mainly for Dolachar and washer reject fuel. We are taking project management and boiler retrofit. See, we have commissioned in last 3, after COVID, we have commissioned 20 boilers which was stopped for more than 12 years. 2012-13 they stopped. We have taken the complete retrofit order. We have put almost 7 power plants, 20 boilers we put in operation, and a few more are in we are doing the retrofit, and that will come to in operation maybe another 2 months time. So this is what our as a company we are doing. And we have group companies, Sri Sai Industries, we are taking care of WTP chemicals and all the spare supply. Amman Enterprises, this company we purchase complete boiler components we are manufacturing, all sort of pressure part, non-pressure part, we are manufacturing there. Sri Sai Electrical and Equipment, we are doing all the panels and doing assembly, designing of electrical system and execution of, these are all the things we are taking care in the electrical. Sri Sai Tech Solution, this is very interesting. We are doing manpower, we are taking from the colleges, around Trichy, around 100 colleges we have manpower selection. We are taking manpower, training them for 3 months and then giving to the companies. In boiler, in last 3 years, we have trained almost 500 engineers. We are using 150 engineers, 150, and we have given to other O&M contractor, owners, everybody, we have given the rest of the people. They are all placed. This is what we are doing. And one more point I would like to communicate here. We are making a system to evaluate boiler field operator, boiler desk operator, shift in charge, plant manager, everyone, and turbine operator, turbine field, turbine control room. For everyone we have a program to evaluate them. This is not to punish them. This is to understand what sort of their skill they are having, what sort of training they need. That we can understand from that. It is simply like, JEE mains, JEE exams or NEET exam. Like that we made program, and anybody want to do, you can call us and we can help them in that. And we can also further what sort of training they require, that also we can identify and give training to them. Okay. Thank you very much. And I want people to ask me what sort of presentation you want next time. Please come.
So thank you, sir. Thank you for your great experience what you have shared. Definitely we will take the questions during the session. So thank you. Now I am going to request from another eminent speaker from the Urja Disha Boiler Technology from Pune. Sir.
Hello, good evening everyone. I know it's the last session of the day, but I have very much interesting value proposals available with me that will keep you awakened, and thank you very much for this opportunity. First of all, the Saket projects and all the dignitaries present over here on the dais and the audience which is available here at the last session of this seminar. So we are Urja Disha Boiler Technologies, your thermal engineering partner, and before going into that interesting offerings, I would just like to give you small brief about our organization. So we are established in 2004, and we are the extended design office for many global OEMs. We are into design and engineering services for various fired, unfired boilers, fired heaters, waste heat recovery energy processes, process integrated boilers, thermic fluid heaters. The unique experience that I would like to highlight over here is the wide variety of handling of dirty and hostile fuels, which we are listening since morning, how difficult it is to combust the dirty and hostile fuels as well as the corrosive and erosive gases. So we have that expertise and experience, and which calls for very completely non-conventional designs and special designs what we possess, and we have expertise. This is just to give an overview on the capabilities what we have done so far in last 20-25 years. So in fired boilers, we have the capability from smallest of 7 kg per hour up to 200 tons per hour of design capability. In unfired boilers or waste heat recovery boilers, we have the capability up to 400 tons per hour. Fired heaters, that is, then we have the capability of design up to 180 million kilocal per hour. Hot water and hot air generators, that is one of the important products we have. The pressure ranging from 10 to 120 kg per cm square, temperature ranging from 100 to 550 degrees centigrade. And one of the unique designs what we have done so far, that is the hot air generators up to 750 degrees centigrade. I think this is one of the designs that no one has done on the earth, that we suppose that we have done that, and proud to say this. And we have the design capability of doing any codes of IBR, ASME or any European standards. Then we have the capability of doing the revamping, the modernization of the existing boilers. Moving on to the next slides, what we have just talked about the different types of fuels that we have handled. These are the few list from the solid fuels that we have handled. Many of them like of interest to you, like palm, this EFB, fruit bunch then palm fibers, cotton stock, mustard dust, MSW, this is municipal solid waste, where we have designed boilers. Then other fossil fuels are there, Indian coal, Indonesian coal, these are there. Then other fuels, what into gaseous and liquid, what we have done, liquid fuels, spent wash boilers we have done. Then the furnace oil, diesel, in the gaseous, carbon monoxide, hydrogen, even coke oven gas and blast furnace gases which are used in steel industry, natural gas of course is there. Then these are the few offerings and the strengths what we have. We have basically a rich database of almost more than 1,000 installations in the industry across the globe in India. What customer can gain from that, from our rich experience is higher efficiency, economical, savings in capex as well as in operational expenses. Another important feature what we have done is capability, because what we have talked since morning is firing the multiple combination of fuels. That is very important, and that's the demand that's been coming out from the industry of having the combustion of multiple fuels under one boiler. So we have the capability of doing that. Then capability of handling the complete boiler island, which covers the complete handling system, then the instrumentation, electrical part, controls everything with air pollution control norms. Then we have the capability of online and offline cleaning systems. The most important part is uninterrupted operation. The designs what we have supplied is giving most uninterrupted operations. We have just said 8,000 hours per year availability. That's the complete whole year. Then other strengths, we have the combustion technologies we do, the designs, the various types of boiler designs. These are traditional single drum, bi-drum, but apart from that we have design capabilities, and we have done the designs for special fuels, for design of tail end type of boilers, then customized waste heat recovery system and waste heat recovery boilers with corrosive and erosive gases. Then another important aspect is process integrated boilers, which has to be within specified limits, needs to be designed, that we have precisely designed. Then spent wash fired boiler with ZLD approach, so we have done that also. Now coming to the special offering which I was talking about. So this is the picture from one of our esteemed customer, Madhu Silica, who are into manufacture of precipitated silica. They are present in Gujarat, having different plants into manufacturing of precipitated silica. Their requirement their requirement is clean air at very high temperature of around 600, 650 or 750 degrees Celsius, but clean air is the main important thing, because contaminants are not required, or that's the requirement of the precipitated silica. To dry the precipitated silica, we are designed the coal-fired hot air generator. Earlier they were using very costly fuel, which is now we converted that into the coal-fired, which is now into multi-folds. They are saving it, and this is now second largest precipitated silica manufacturer in Asia, with the economies what they have.
Not in Asia, in world.
In world now, yeah, that's the correction. So we have designed a coal-fired hot air generator for them. So what all advantages that we have done into designing of this hot air generator, by using different technologies, by putting very good emission levels or upgraded to that design. Introduction of the shock zone, it's one of the important things, because it is experiencing very high temperature of around 750 plus, and we have developed or designed special metallurgy and tube geometry so that it will take care of that shock zone. So these are the few aspects that needs to be considered while designing of this generator: metallurgy, product quality, tube geometry, and of course the refractory engineering. If anything goes or any error happens during this selection, then the entire life of the product will be disturbed and you won't get the service. These are few reference list of hot air generators. Already I have mentioned this Madhusilica we have GMGB, Gujarat multi-gas base, where we have supplied or designed these hot air generators. Aarti phosphate, they are the few names what we have. Now we have the requirement apart from the coal, we have the requirement of using the biomass for these hot air generators. That design also available with us, and I am proud to say that these designs are working since last 10 to 12 years uninterruptedly and continuously. Then the second offering, what may be interest of you, is pipe-in-pipe type of heat exchanger, where you will find the slurry coming out of the precipitated silica that has got the ability to transfer the heat. But this is a special design wherein you will put the slurry into the pipe, and from the outside you will enter the cold liquid and the heat transfer will happen, and that hot water can be used for your processes and it can be thrown back to your process for any other use. So this has a tendency of, if you use any other conventional heat exchangers, then they have the tendency of clogging or fouling. But with this special type of heat exchanger, you can get away from this and you can achieve the heat duties. We have done the projects from 1 million kilocal to 100 million kilocals of this type of pipe-in-pipe heat exchangers. These are the few pictures for what we have designed. Another interesting offering what we have, the last one, the condensing economizer. What we have learned from the morning, there is a condensate available into the flue gases which can be condensate and which can be reused. So basically these high moisture fuels like bagasse or any other gaseous fuels like having the high carbon content like natural gas, they have a good moisture level available, and we can condensate the moisture into the in the flue gases which are going into the stack by putting the water, and the heat exchange can take place between them, and that hot water which is coming out of this process can be used for many other uses into the process, and the condensate what we collect into this process can be used for many, where water scarcity is there, we can use that. We have just given one example. These are the few features or benefits what you gain by installing this condensing economizer. Of course, the increase of thermal efficiency, electrical output, fuel consumption in the utility plant, that as I explained how the circuit is, then supply of heat for the plant processes, then reduction of moisture that is going to the stack. These are all benefits that you achieve from this equipment. This is just one example exercise what we have done for the capacity of 10 TPH natural gas fired boiler with 10.5 pressure and 186 degree outlet. So incoming flue gas is around 120. We have designed the outgoing flue gas after condenser at 60, incoming cooling water which is going to condenser at 30 and going out is 90. So the economy is what you are getting here. It's really eye-opener to everyone. So if you see the benefits, it has turned out to be 230 lakhs, it's 2.3 crore per year. With the investment into this country, we are getting the payback of almost 6 months, 6 to 12 months you will get the payback. That's kind of economies that you are getting from this equipment. So this is our global presence that I have explained. These are the few clientele list, esteemed clientele list from our side. We have a very good team of 40 plus technologists and supported by our state-of-the-art infrastructure in Pune. We can deliver it best to the customers. Thank you so much. Thank you very much for patient listening. Thank you.
Thank you, sir. So now just I'm requesting to the all of the audience that what they have their query regarding the today this last session, so they can now the open, they can ask any question from our panelist. So please.
It seems all are tired.
Our sir has traveled the more than 2,000 kilometers, and they have so much of enthusiasm and so much they have energy that they came here to discuss to all amongst, right? So this is also, we have the great honor to all you sir.
Thank you. Sir, we work 24/7, sir.
Great.
So we are people, if any problem comes, we will be happy. Oh, I have something to learn. If some problem comes from the plant, we are happy.
Okay, now so just I'm just sharing the vote of the thanks for this the third session. Yes, please.
Sir, if anybody wants any particular type of presentation in future, please, I want at least 1 or 2 people to give, I want this type of presentation, please. Yes, sir. Huh?
Boiler safety.
Boiler safety, okay.
From Madhu Siliga.
जैसे सर फ्यूल चेंजेस हो रहा है ना, जो इंडियन कोल 70% और डोलाचर 30% के हिसाब से जो बॉयलर डिजाइन है उसको आप लोग 30% डोलाचर और 70% डोलाचर 30% इंडियन कोल के हिसाब से
Already we did 18, we assured a 70%, we are running 80%.
Yes.
With the 2300 calorific value is the combination of fuel.
तो उसमें सर फार्नेस जोन में या फिर बॉयलर में क्या क्या डिजाइन चेंजेस आ रहा है?
ओपन बॉटम डिजाइन किया है एंड इफ इट डिपेंड्स ऑन योर बॉयलर, तो आपका जो बॉयलर कैपेसिटी एंड फर्नेस अरेंजमेंट देंगे, then we can identify. See, the problem, that boiler was designed for 60% to 100% load for superheated temperature. After modification, we made such a way that it is giving 25%, it is giving the steam temperature of 485, 490 degree, and that plant is little difficult. No, daytime they get more solar energy, night time they operate a power plant. It's a cement unit. So daytime they may operate 3 megawatt, night time they operate 11 megawatt, 12 megawatt. So both the condition we have designed. So it is possible.
तो उसके लिए सर फार्नेस जोन में या फिर बॉयलर में जो जो डिजाइन चेंजेस आए रिलेटेड जो पीपीटी वगैरह जो बोल रहे थे ना,
वो डिजाइन प्रेजेंटेशन कितना पैसा देंगे?
नहीं सर, वो लर्निंग के लिए, जस्ट लर्निंग के लिए आप बोले।
लर्निंग के लिए मैं आपको इन्फॉर्मेशन दे दिया। डिजाइन आई हैव टू वर्क।
नहीं आप बोले ना कि क्या क्या टाइप का
नहीं
चाहिए।
I can give you a design. See, I have given you that air heater I have replaced and I got a benefit of 2.64 crores. That means that is an indication. If you do a performance, there is a possibility. Then see, आपको this forum is for learning. Everybody learns. Everybody understands something and learns. आपको मैंने इन्फॉर्मेशन दे दिया, आप जाके अभी अपना दिमाग लगाइए कहाँ मैं कर सकता है, वहाँ पे थोड़ा डिजाइन होगा ना, देन यू कम टू फॉर डिजाइन स्टेज. सी बिकॉज अगेन if you do a design, lot of people involved, and drawing you have to make, detailed study you have to make. I can give you a study, performance test, I can give you a study. This is the area for potential energy improvement. This much saving I can give. But again, implementation, that is again big engineering. That
we can give.
Okay, thank you sir.
Thank you. So I will give more case studies. What are all the modification done? What are all the cost saving? That case studies I will do. That is okay for you? Detailed design cannot be given.
So it is very interesting, sir. Now the time for the vote of thanks. So first of all, I am just thanks to the.
But anyhow, I wrote down case study for higher product chart firing presentation.
Actually, sir,
हाँ हम लोग सर जितने बार डोलाचर 70% में चलाने का कोशिश किया, विद इन 15 डेज जो किक आउट जोन का रिफ्रैक्टरी है वो डैमेज हो जाता था, और अब
CFB में
CFB से
you can give an opportunity, I can send
हाँ।
some of my special.
और लीकेज आता था टारगेट जोन में, इसीलिए मैं आपको ये पूछ रहा हूँ।
सर कौन सा यूनिट है आपका, कहाँ पे?
मैं एक्चुअली लास्ट प्लांट मेरा रूम था छलिया में, स्टील प्लांट में था, तो वहाँ पे ये मैं ऑब्जर्व किया था।
कितने टन का बॉयलर है?
वो 170 TPH का
CFB.
CFBC वाला।
Chinese में
नहीं IJT।
IJT, okay. That is a posterior design.
Yes.
But if you give a particular failure pattern or something, see, overboard by mail everything free, but coming to site it's cost.
Great, sir. So first of all, I thanks to the Mukund sir for insightful giving the ideas about the recovery condensate and the KPI performance, factor of performance, and one most important thing sir has discussed about the steam accumulator. Yes, so whenever we have the process plant are there, so we know that how much the process fluctuations are there. So that is the best the design that we can introduce to cope up with that. That is the steam accumulator. Then the Siva sir, he is already committed to the lots of the thing to share the presentation and discuss over the phone. Right? And
Already I sent to my technical team your requirement. Next year it will be given. But not complete design. I will give you what we did and what is the benefit. That will be there.
yes, and next I thanks to the Urja Disha boiler technology team, and he has already presented the good. The thing is about the which is I also think that is a very nice. It is about the hot gas generator. Hot air generator, right? So, and I'm just so much the surprise that the sir has told that its payback is just what we can say the 6 to 12 month, right? So I think it is so much. It is a great the thing, and economically we can, if it is required, then we can go with that. So thank you to the today all. The panelists and especially for all the audience, and I especially believe that this is the what we can say the place where each of the audience are getting the something and they are inspiring and they are going to implement the new ideas in their plant, right? So this is the what we can say the vision for the Steamtech, right? So he is continue these things and hope that the similar with this energy we can again meet in the next year. So thank you to the all. Thank you.
Thank you so much, sir, for the wonderful session.
So you are keeping the live programs at the last because keep the audio, but nobody.
Friends,
Very less.
let me take this opportunity to thank each and every person who has participated in this conference. Let me not also forget the sponsors, the speakers, and the guests who came today morning. This time, in a couple of days, we are going to send you a suggestion format. We are thinking about taking this conference now to the next level because we have completed 15 years and we need to go to a higher level of organizing conferences. We would need your suggestions. We would need a lot of feedback about the conferences that you have all attended so that in the next version, when you arrive here in 2025, you see a conference which could be different, which could be much more impactful, much more purposeful, but for that, it would be you who will have to give us some suggestions. So you will get a feedback form wherein you can send those suggestions, and let me assure you that next year when we organize this conference, your suggestions will be considered and taken care of. Once again, I thank you all very much for being here, and let us call it a day with a resolve that we are going to contribute to making this earth a better place to live. Thank you very much. Yes.
No, you see, ours are lively program. Case studies, where we need the existing design, there is a change. So it's all our users.